Hi, everyone. Thanks so much for coming. I see my clock is ticking on the speaker view, so I'm going to go ahead and start. Thanks so much for the chance to come and speak today about something which I know is very much a continuity throughout a lot of the sessions here about artificial intelligence. I'm going to try to make this talk as library-centric as I can, and really just, I think, what's less important in my talk is what we're doing at Stanford. What's more important are these library-wide conversations about the future of research and the ways that libraries can be engaged, the ways that libraries can and have been engaged, as we've seen from colleagues at Harvard and Yale and many other universities at this talk at this conference are going to be articulated differently. So what I'm showing here is less a kind of paradigm and more just a framework for a set of conversations that I think we need to have as a field. And I do think it's valid to talk about the intersection of artificial intelligence in the library, primarily because a lot of the work that we do today and that we have been doing for decades in the library is absolutely central to not only the technological developments which have resulted in the current sort of transformers moment in AI, but also the core research tasks and intellectual tasks which are a part of a lot of AI workflows. And one way to think about that is to think about the library's involvements in transformation of physical material into digital form, and also the creation of what we might term embeddings, or reduced dimensionality representations of very complex material. I'm sure everybody in this room has at one point or another run OCR on a printed book. You might have done this, in the 90s with OmniPage. You might be doing it today with Adobe Acrobat or Adobe FineReader. Whether you want to or not, when your modern cell phone is taking a picture of a printed page, it's OCRing it on device without your consent. So these transformations of cultural heritage material have been going on for a long time. They're happening almost automatically. What had been very difficult for many of us in the room, and what was sort of unimaginable until about 18 months ago, was stepping beyond optical character recognition into fields like handwritten text recognition, or recognition of the human voice, automatic speech recognition. But we now know through systems like Whisper and TROCR and things like that, that we're going to be able to take the human voice, human handwriting in dozens of languages, not just English, and transform that into a Unicode equivalent. With images, we're getting this amazing ability to do text-to-image models, as we've seen some really important work from the National Library of Norway that's opening up amazing discoverability and search opportunities for undescribed visual collections, very much along the lines of what Carolyn and her colleagues were showing just on the embedding search on their existing catalog. The notion is the same. We're transforming very complex objects many times into text, such as OCR, in some cases into very complicated sort of text-to-image networks, as with CLIP. And we're actually going to see, I think, multimodal models emerge over the next couple of years, which are going to be capable of understanding very complex forms of culture, like film. So if you think about an Ingmar Bergman film, you might have a soundtrack, you've got the voice, you've got the Sven Nykvist cinematography, you've got all sorts of sound effects and camera motion. All of these things are going to be understood by a multimodal model that's going to produce embeddings that might allow us to search through cinematic history. So that's the context of how a lot of our work in the library has been and is still involved in some of the core notions of what makes up LLMs, which is transformations and embeddings. However, when you talk about AI today, it seems that we've had this kind of reduced conversation where the one sort of metonym, the sort of pars pro toto for all artificial intelligence is like this one free service online that you can just go to and chat. And I think if we speak with a lot of our undergraduate students or even some of our researchers, that's just what people are doing. They're going to chatgpt.com or whatever it is, and they're just pasting, copyrighted, licensed, private information into there and getting the result. And that is happening. I have no doubt that's like 98% of all AI right now. But in fact, we're looking at a really interesting, complex research ecosystem for artificial intelligence, which goes way beyond one for-profit company. Many of you in the room have heard yesterday about Yale's Clarity efforts. Many of you also have this identical enterprise wrapping of AI services through Microsoft Azure, Google Cloud Compute, Amazon, ways you can actually get the OpenAI model from OpenAI, but through Microsoft. Many of you on campus work with or maybe connected to high-performance compute, or maybe you have a national center for supercomputing applications on campus. That's another AI center, another place where work is being done. Increasingly, there's work on local GPUs and even into what we call edge devices, which are essentially multi-billion parameter models that are running on your cell phone. So if we think about this research landscape, this continuum I just put up on the screen, it's actually been developing really quickly over the last couple of years. It was in 2022 that we started getting these large language models hosted as a free service. 2023, we started to get some open large language models being released. I put open with an asterisk because it's never quite clear how these models are trained. The weights are freely distributable, which we really appreciate, but you're never quite clear exactly which pirated ebooks were used as the training material. And I think over the last year, in 2024, we've seen incredible maturity in software to let us run local large language models on our own computers, integrations into operating systems, whether that's Galaxy Intelligence or Apple Intelligence. All this stuff is coming to your cell phone, whether you want it or not. And as I mentioned before, this sort of connection to the enterprise academic IT, which is often proxied through Microsoft. So if we think about this actual very rich, interesting continuum, just to mention these enterprise services right now, this is Stanford's on the left and Yale on the right. The branding is different, but the concept is the same. You're able to take these models, run them in a kind of private cloud, have a little bit more assurance of data integrity and safety. You may get free credits. There may be sort of uncost recovered, at least at this point. That's really exciting. Similar things are going on. I know Australian National University in Canberra also has a similar deal. I think many R1 universities will be committing to these deals if they haven't already. But what I actually want to talk about today is something that is another place on this continuum, another place on this spectrum, and that's the notion of doing work locally on a GPU, on a computer that's actually right in front of you. And there are many reasons why you might want to step back, even from the private cloud, even from the enterprise cloud, and think about doing work on an actual computer in front of you, like we used to do in the 90s. And one reason is that even when you have models which are proxied through Microsoft, you still have the challenge of sort of software as a service and the difficulty of being able to pin and actually cite and replicate research done. As these models get better, they get better in all sorts of ways, sometimes for really good reasons, but they're not really capable of offering the same model weights that you might have used a couple months ago. This is far more true in commercial services like ChatGPT. I'm sure the enterprise wrappers have some affordances for this, but there's nothing like the guarantee of saying, I got this result from a series of model weights locally on my hard drive, and I can offer these as a kind of research artifact for people who want to replicate my work. The other reason, and this maybe has more to do with my programming skill, but every mistake you make with like with a commercial license for ChatGPT costs you money, right? You're using up tokens, you're using up credits. If you have a powerful computer in front of you, you can make as many mistakes as you want, and you're sort of amortizing the cost over all of that work. And finally, I think there's a lot of interesting arguments for data autonomy. The most autonomous computer is the one that you can hold in your hands, that's on a desk in front of you. One of the really interesting aspects of this, which I hadn't considered until recently, was the very understandable and laudable safeguards that are set up in non-open large language models to protect against expression of violent or harassing or any other type of material which might be not befitting a for-profit company's image. But if you're using a large language model to translate from Turkish into English, for example, and you find that your model is refusing to give you a translation of a particularly bloody battle between two opposing forces, you are essentially caught in a kind of commercially engineered refusal situation where your large language model thinks that the content you're pasting into it is way too violent. And these are not problems that you face when you have an open source model, or especially a model that's been obliterated to remove that kind of refusal. There are other reasons. There's nothing more secure than having a computer that's just off the network. You don't have to rely on any CEO's claims that he or she won't be training on your material. And there's also just the fact that some people don't trust a guy with two popped collars to be in charge of their data. And I think that you're not mutually exclusive. I think we have many researchers who try something out with a free ChatGPT. They may not even be on the VPN. They're at home. They're on a cable modem. They're logged into the kind of enterprise wrapper. They're just pasting this into the free ChatGPT to see, can a large language model help me with my problems? They may then scale up. They may take the effort to log into the VPN, to come to campus, to use one of these great services which Central IT is developing for many research universities. They may come to an artificial intelligence lab in the library in order to do that work. And hopefully they will end up on the high-performance cluster at many of our universities, where people who've been doing this kind of work for decades can really give them a lot of great support. Given this context and the fact it's not a zero-sum game, it's an and game, not an or game, I want to talk about three forms of library services for artificial intelligence that I think the library can be very helpful with, and this is basically advice, access, and action. When it comes to this infrastructure, this universe of possibilities, the spectrum, I think we can obviously give advice. We can refer people to this, what we call the Stanford AI Playground, the enterprise wrapper. We are already referring people to the High Performance Computing Center. And when I say access, I primarily mean access to data sets in which can be processed on either local high-performance computing systems or on this enterprise wrapper, which has sort of guardrails and safety systems to make sure the data doesn't leak. What I'm primarily going to talk about today is actually not just advice and not just access to data sets, but actual action, and that depends on having local GPUs in the library. So let's jump into that. First of all, advice. This is core to what we do, and a lot of these people are not in my group. They're in wonderful groups of subject expertise, subject curators. Nobody in the room needs to be reminded of how much experience and expertise is in the brains and the hearts of subject specialists. They know everything about what the library's collected, in many cases for decades. They know what's coming in now and hasn't even been cataloged. They have many connections in the field. In my group and in other groups at Stanford Libraries, we have a lot of wonderful tech people who've done some of this work themselves, AI work. They know how to avoid common mistakes and can give advice on what is likely to work, how long is it going to take. We also offer a lot of training at Stanford Libraries, both software carpentries as well as specialized AI and machine learning workshops. And I think of this advice as a core component in AI research, especially for junior scholars or for folks who are just getting into this work. By access, I mean primarily access to collections data, and oftentimes that just comes with the knowledge of this collection, the fact that we have this digitized newspaper from Singapore, or we have these records of shipping traffic over the last year. This could be open data, it could be proprietary licensed data, which unfortunately we can't share beyond the university, but which any Stanford affiliate is able to use. It could be our wonderful rare and special collections. And there's also access to application programming interfaces, the ability to find a geolocation for thousands of addresses or to pull images through the IIIF API. There's a lot of other great things that the library can offer access to that are helpful in AI projects. But let's come to the core of this, which is action. What we're building at Stanford Libraries is a room that has local GPUs at which you can sit down and actually do work. And so there's a hardware and a software component to this. There are some relatively expensive, but not like crazy expensive video boards, which have large amounts of what we call video RAM or VRAM. And these are essentially NVIDIA boards that were, originally designed for 3D graphics, but they are essentially accelerators for linear algebra, which turns out to be the core component of a lot of neural networks. And so by sitting down at one of these machines, you have the ability to run a local large language model and to do so with a very high parameter model. It could be a 32 billion parameter model. All of that power is useless without software. And so what we've actually going to be deploying in this lab is some software called LM Studio. Can I ask for a show of hands? Has anybody used or heard of LM Studio? Okay, that guy at the back. This is actually really interesting. I'll show some screenshots and movies of it in a couple minutes. You could use other software. There's interesting software called Chat with RTX from NVIDIA. There's Whisper, which is the speech recognition software. You could run that model locally. So if you do have anthropological recordings, ethnographic recordings, which you don't want going to the cloud, these machines are powerful enough in order to do that speech transcription for you. This is essentially a call to reimagine the computer lab as a site for local inference, as part of that ecosystem of possibilities, going from your cell phone all the way to high-performance computing at NCSA or whatever. LM Studio is free sort of software that anybody can download. As you can see here, it's actually available for 3 platforms, for the Macintosh, for Windows, and for Linux, which is really exciting because we can run it on sort of bog standard Windows machines with all Stanford security apparatus and not have to worry about complicated installs. Far less complicated to install than like Adobe Photoshop. And what's kind of interesting about this software, I'll just show you, this is actually something I ran this morning on my computer. So what I'm doing is I'm going to my little MacBook Air and I'm saying, please load this 3 billion parameter Llama 3.2 model. It's going to do that. It's going to load that on my MacBook Air. And then I'm going to ask it for an explanation of a quote by Jane Stanford. And you'll see, we pay attention to the box on the bottom left. You'll start to see the blue line go very high. That's like the GPU inside my computer that is basically being used as opposed to the cloud to be able to infer against this Jane Stanford quote. I will note this software, LM Studio, was highlighted by Apple in its recent product introduction a couple months ago. It's very interesting that Apple's doing this. They're promoting, you could see, and this screenshot makes it look very technical. It's actually not that bad. It's just software you run, which has a chat interface. It has a wonderful search engine to say, I want to download the Llama weights. I want to download the Gemma weights. It has a great search engine into a Hugging Face backend. And it actually does some really nice things like figuring out how much video RAM your computer has and saying, well, you can download this size model and it'll fit within your GPU. So this is the software we want to deploy there on these Windows machines with nice NVIDIA boards. We think it's a very easy story for students who want to play around with different models, evaluate them, see what they can do. LM Studio also has affordances for if you have a vision model, a model that's capable of understanding what's happening in a photograph, you could upload that. You can even upload a couple PDFs if you want to play around with retrieval augmented generation. So let's talk a little bit about service components. I've talked about the computer lab. Let's talk about service components that go along with us, because as we think about advice, access, and action for AI, we have to think about a service model. There are three really important components in this, and I'm going to give short shrift to the first one, which is curation. I'm going to focus mostly on modeling and inference, although curation is, of course, as we know, data cleaning. It's 95% of your work. We actually have a new research data curation group in my team at Stanford, which is really exciting. They're incredible. The curation is not always needed if a lab brings with them their own data set that they've already curated. It may not be needed if your vendor is providing a relatively clean data set, but it's needed in almost every other case. And it's kind of interesting that even NVIDIA is starting to talk about data curation as a task that it wants to write software for, because they understand how important this type of stuff is. Let's move on to modeling. And I think the main thing I want to say about modeling is that there is, as everyone in this room knows, an incredible amount of intellectual effort in the task of modeling. Modeling, when I use that word, it could be evaluating existing deep learning models. It could be fine-tuning or applying a transfer learning method in order to take an existing open weight model and adapt it for a particular task, like translation of Ottoman Turkish. Or it could mean, in some cases, training new models from scratch. The key thing to remember in all of this is that the map is not the territory. The model you're building is supposed to be wrong. It's also supposed to be useful. And as Bell reminds us as early as 33, what we often do is we make a mistake in thinking that we have to build a one-to-one map of the world, which is the mistake that Borges warned us against. So there's intellectual effort in producing a model, considering and choosing from a model, fine-tuning a model. And it's actually kind of interesting that this goes down to the brass tacks of thinking about text. Most of the people in the room will know that LLMs don't actually work at the word level, they work at the token level. What the token is dependent on the large language model architecture. It's oftentimes a kind of slurry between characters and words. So it's not a bag of words model, it's a bag of kind of sanded off and sort of particulate items that have a relationship to linguistics but are not tokenized on word spaces. And it should be important for all of us who work with LLMs to understand how tokenization works. It's a key component of the model of the world we're building. I have a colleague who's working on pose detection in theater together with theater and performance studies professor Michael Rao, and he's working on how the human body is held in theatrical recordings. But even something like that, you have to decide how to represent the human body. Is the human body conceptualized as a skeleton, as an assemblage of boxes, or is it a volumetric mesh? These are all modeling decisions that you have to make. There's no right or wrong answer. It depends on the question you're asking. Really excitingly, there's also work going on foundation models for planet Earth. And by a foundation model, I mean, think of that as sort of like a large language model, except for something different than language. Why our GIS team lead, Stace Maples, has recently told me about some of these amazing foundation models, which are coming partially out of the nonprofit space, the Clay Foundation, the Earth Genome Project. They're essentially building models like sort of large language models, but in this case for Earth observation. So they understand what are trees, what are rivers, what is an asphalt, what is parking lot. And because they have that foundational understanding, you can actually retrain them to look for something specific. For example, deforestation or a new road through the Amazon, which might point to an illegal gold mine. So this notion of choosing a model and taking a foundation model and fine-tuning it for a purpose is a kind of intellectual effort that is incredibly crucial to the future of research. And it's very vitally important, I think, that our librarians, our sustainability librarians, our GIS librarians know about this. Luckily, they do, and they actually told me about it. We also have researchers at Stanford Medicine who are actually producing foundation models for healthcare. This is the lab of Nagam Shah. To be clear, he did these models. He didn't need help from us, although we did play a small role in cataloging and saving his data. But he has a couple models that are available on Hugging Face, which are really interesting to look at, a foundation model for healthcare. So in every field, from Earth observation to healthcare to literature, we're seeing this modeling come up as a core research activity. Inference is just asking the right questions of the model you've chosen. And it's not as simple as you might think, as we know from some of the online discourse about people mildly dissatisfied with their results from ChatGPT. Part of this is prompt engineering, prompt design, knowing what kind of questions to ask. It might also be structuring the results, getting a model to only output in a certain format like JSON or XML. And of course, the key effort here is interpreting the results. And these are all areas we hope to provide expertise on. We're already providing advice on. I will, just to return to Dr. Nigam Shah's work, after his model was trained, we used some Stanford Library infrastructure, the Redavis data farm, based on the Redavis platform, to share the ground truth behind one of his foundation models for healthcare. This is a really exciting way that data sharing can be used in the context of large language models and AI research. The notion here is if there's let's say a hypothetical health outcomes model, I might want to look at the model. I might want to think about how the model was built. I might want to ask questions of the model or do inference. But I also might be interested in what patient data went into that model. Were there any left-handers? Were there any women? And so a platform like Redavis lets you go in and look at all the records. And believe me, these have been anonymized and went through 7 layers of review. And say, is the ground truth that made this foundation model representative of the work I'm trying to do? We saw some interesting talk by Javier de la Rosa from the National Library of Norway in Canberra recently about his work on what happens when you put sort of fiction and other in-copyright literature into a large language model. Same question. You're interrogating the sort of ground truth behind the model to have a better understanding of how the model is inferring. Finally, some organizational thoughts about how my part of Stanford Libraries is changing in order to help support AI modeling and inference as a service. We do have an organizational chart. The organizational chart isn't all that's interesting. What's interesting is the connections to and from the organizational chart. We are hiring a new person. That we've got some great candidates for that position. The position is actually still open if there's anybody looking for a job. But what we said in the job description was we want somebody who's a powerful advocate for AI, but also understands its limitations and knows what we should not try to do with AI. And we think that will be really crucial in picking the right candidate for this manager of AI modeling and inference. We're also changing how we work with faculty and grad students. We've had incredible success working on a year or multi-year time frame, which has resulted in some amazing projects like that pose detection project I talked about before. But we're also going to start working on shorter time frames. We're going to try to be a little bit more nimble and help people discover very quickly if AI is going to work for them or if it isn't. I want to sort of tease out some of the relationships on the right side of this chart, this organizational chart. Many of you in the room might have heard of Stanford Library's Academic Technology Specialist Program, which goes back many years. Matt Jockers was actually an academic technology specialist a long time ago. And the connections between those people who are embedded in departments such as history, or anthropology, or comp lit is incredibly important because they are literally in that anthropology building and they have, in some cases, decades-long relationships with faculty. We don't have ATSs in every department, but their disciplinary and departmental level expertise about how AI is being talked about in the field is already informing and will continue to inform our AI work. Speaking of GIS, Stace Maple's Stanford Geospatial Center, the intersection between AI and geo, as we've talked about, is really epic. We're having a AI plus geo meetup next week in Stanford to talk specifically about this. And finally, as we talked about before, the intersection between research data curation and what you have to do in order to assemble ground truth and build a model is one that we think is incredibly important. And that's why these 3 groups, our academic technology specialists, our GIS team, and our research data curation team, are going to be key inputs, bidirectional connections to our AI lab. So here's the final thought. Local AI sitting in front of either a nice Mac Studio with 192 gigabytes of RAM, which can load an enormous model, or a unfortunately too expensive NVIDIA A6000, which can also load a very, very large model, is one component. It is not going to replace people pasting private data into ChatGPT. It's not going to replace your phone doing inference without your knowledge when you take a picture of something, but it's an interesting component in this spectrum, in this universe. And it's easy to see how all research today that uses AI is influenced by both intellectual questions of modeling and intellectual questions of inference. These things are present in every single phase, from my iPhone all the way up to the National Center for Supercomputing Applications. The difference is on a local computer, you have a lot more control about what model is used. And finally, that I think it's easy to suggest that libraries should not give up on and should instead embrace this possibility of offering advice, access and action, regardless of where this is taking place. But certainly within local AI inference, we can offer that chance to turn ideas into action. So thank you so much. I think we have just a couple minutes for questions if there's anybody who'd like to ask.
Do you feel like you have a neat framework, not in the cool sense, but in on how to deal with sort of the research compliance, IT security elements of the work?
That's a great question. Of course, there are whole bureaucracies that are worrying about this. But I will say in one case, we had a doctoral student from a professional school who was looking at National Opinion Research Center data, NORC data. I think it was Workplace Survey, which is held to a very high security standard for whatever reason. So what we were able to do with her, she was actually one of our beta testers. We could load a large language model onto one of these NVIDIA computers, Dell computers with an NVIDIA board. We pulled the Ethernet. We air-gapped the machine because once we had the model weights and loaded them to LM Studio, there was no need for any live internet connection. So I believe when she wrote her data security plan to NORC, she said, this will be an air-gapped computer, and I'm doing certain kind of LLM moves in order to analyze the sentiment of these texts, but there's no live connection. It's even safer, although there's nothing wrong with these enterprise wrappers that people have signed the deals on with Azure. Those are great. I'm sure those are also bulletproof, but if you're trying to convince an agency to give you a really secure data set, being able to say it's air-gapped is one thing that can be also very helpful.
So in your partnership, I don't see anybody waiting at me. In your partnership, are you engaging IT security in central IT, in the research space, in terms of how it is that you're moving your collaboration forward, or is that not a critical component of how it is that you're thinking about the partnership?
Yeah, I think it is critical, and we do have a chief privacy officer at Stanford. We also have folks within the vice provost and dean of research office who care a lot about privacy. They often think at macro scale, like how do we keep all these patient records safe? We have a monthly or so call for research data, which brings together our amazing business school and medical library and all sorts of folks who help with research support. And this topic has been much on everybody's minds. I think what I'd love to do is to get this local GPU service stood up and formalized, and then present on that in that context and get people's feedback around there. You know, nothing is a magic bullet. Leaving the USB stick in the computer for the next student to discover is a mistake. Not erasing fully, not encrypting the hard drive you're working from can be a mistake. So we all have to think about ways in which things can go wrong. But I'm more confident about controlling some of those variables on equipment that I know about and have physical possession of than I am in some other scenarios.
And quickly, your opinion about de-identification of data versus synthesized data and the use of research.
That's a great question, and we're actually seeing some LLMs being used to generate or synthesize data, which I think is discipline-specific, whether people will accept that or find that anathema. But that's a great question. I do think, I didn't have time to go into it, but using LLMs to de-identify data, or at least to find social security number patterns, credit card number patterns, is something I hope my data curation group investigates.
Thanks. This was very enlightening, and then also interesting to see some parallels with what we've been doing locally. And one issue that we've confronted at the University of Nevada, Reno, in terms of our internal discussions as a library, not necessarily in terms of standing this up as a public service, although now I'm very interested in that, but in terms of our back-end work with digital collections and so forth, is that we've encountered some understandable concerns about the impact of these services, especially environmentally, ethically, some of those things. And I'd be curious to hear if you've had any discussions at Stanford about how, you know, it's not a perfect solution, but some of these local deployments actually can address, at least, or mitigate some of those concerns. Because I know that people on our side feel more comfortable when we run it locally, because at least we're not querying a data center, you know, or at least we're not kind of engaging in that sort of exchange.
I think that's a great, you know, there are other amazing tools to go out there and say, where's my power coming from? In California, Pacific Gas and Electric, you could figure that out from the Pacific Northwest at maybe hydro, and then you have to figure out where's my Amazon data center getting its power from. One of the real spaces to watch in this is actually the edge devices, because if you're a cellular phone manufacturer trying to work with the sort of power density of lithium-ion batteries, you are highly incentivized to be efficient in ways that, supercomputers aren't or haven't historically been. The eco question is really crucial, and I'm glad that it has been you've heard that in a lot of different presentations here. We use electricity in all sorts of weird ways. We keep lights on in rooms in which nobody goes. We don't even have simple infrared systems to see there's nobody in the room. We keep LCD displays going in parts of the building that nobody is in. So I think there's all sorts of ways to waste electricity. And I do think that one of the things that we have no insight into, no transparency into, is how these corporations are training models. We can read Microsoft's Green Report and they say that, oh, just kidding, because this isn't being recorded, right? That we've blown past our goals for climate impact because we were training all these models, because we're trying to produce a model that is better than ChatGPT, because we have this strange relationship with Sam Altman. That's happening without our agency and without our control. If we sit down with a research engineer and somebody translating Ottoman Turkish and say, let's do this efficiently, let's get the training data right, and let's train a model and be really thoughtful about it. That is using electricity, but there are also corporations spending billions of dollars for commercial purposes. And I think it's important not to sort of hair-shirt ourselves into trying to stop the work that really is our mission when there are many larger users of electricity than us. Thank you. Great.
Hi.
That's one more.
So I will admit that when your job ad came across, our library circulated it because in the vision section, you ask for someone who can foresee the impact of AI on academic research, which I think is a difficult skill to say you have, and also one that's difficult to assess as part of your review. But it also asks specifically for someone with expertise in the digital humanities. And everyone I know in the digital humanities would foresee the impact of AI as being apocalyptic and dystopian rather than productive, especially considering the environmental impact of AI, the unfair labor practices of most of the corporations, and the fact that we've already seen at UCLA this week that they're replacing faculty with AI at universities. So how will this position kind of lead those conversations and make sure the work you're doing is informed by the humanities and humanistic inquiry?
That's a great question. I come to Stanford with only 2.5 years ago. And before that, I was at a university in Connecticut. And I would say that university, its self-image was very much as the humanities were at the core. And Stanford has incredibly important humanists who've done groundbreaking work. But if you look at the numbers at Stanford, there are more people in electrical engineering and computer science than there are at the humanities. So I've been sort of interested in the two different cultures that I've experienced at this institution. And I would never claim to speak for all humanists at Stanford or to try to summarize the work of very thoughtful people who are thinking about some of these questions. I can speak to my own background as a digital humanities person. And I can also say that most of the people on my teams do come from the digital humanities tradition. I can't speak to who we will hire. We have great people, and I think both sides of the equation are well represented in that hiring pool. But I think that is one of the reasons we put that language in the job description, was the desire to have somebody who would not just blindly push a button or try something out, but be conscious of downstream effects, and that maybe a expectation that they engage in conversations with faculty and grad students too, because we don't want this person to be sort of somebody who operates only on their own beliefs, but rather somebody who reflects the tone or tenor of the campus. I can say that, I think perhaps a good topic for a future CNI roundtable would be the way AI leadership is articulated on research university campuses. There's a wonderful gentleman, Kurt Langwoltz, who's a medical physician who has joined the Vice Provost and Dean of Research office at Stanford, brings with him decades of experience with artificial intelligence in the medical imaging space. And it was really exciting to see somebody with so much experience and background come in and try to offer leadership to the campus in the space of AI. But I think the questions you're bringing up, the negative and the positive valences, would be a wonderful topic for a future CNI roundtable and how every campus, including UCLA, is dealing with these questions. Thank you.